There, I'm Max Doolin, and I'm the founder of the Spokane Cyber Cup. Right now, we're going to talk about the Miner CTF Challenge. If you ever heard of Bitcoin, it is a cryptocurrency that's taken the world by storm. And you've probably heard of the term mining before, how people got rich from it and how it makes the network secure. But you may not know how it actually works. I think I have it here. Yep, okay. So here we have a value that appears random besides the large amount of zeros at the beginning of it. The process of mining is taking data that or all of the transactions or money that we're sending, stick it into a group and hashing that data over and over and over again. Now, when we hash that data, the goal is to get it to have a bunch of zeros at the beginning of it. You can do this by attaching some random data to the beginning or the end of it. I actually don't know what it is on Bitcoin. So if you get something with enough zeros, then you've met the required difficulty of a given block. And whoever can do this first is the block miner and will profit from it. For you guys today, I have repurposed this in a simpler setting. So if we go to challenge.md, we're gonna talk about mining. For this challenge, we have a server for you to interact with in Python, which is running right here locally, but during the contest, I'll have this running remotely, of course. Your goal is to get something that has, I think, 5 zeros is what we settled on. So ignore my 7, but 7 is also doable if you write your code in a good enough fashion. So if we look at the server code, it's pretty simple here. We've got the question route, and with this route, you send it some data. It has a proof ID, so you can get it later, and then it sends it to you with the time. Then you need to answer that. And when you answer it, you need to make sure that you have it with a hash that is small enough. Sorry, a hash with enough zeros in it that demonstrates that you've completed it. And there's also a time check. So that's what the server looks like. Luckily, I've also written a miner file for you. And this has a lot of the same stuff, like checking to see if it has only zeros in it. It gets the attempt and it sends the attempt. Now, your goal is to do this over and over and over again until you can find a hash that has the right amount of zeros in the front of it. Ignore the 7. It should be 5. I think I tested it with a friend. That's what we decided. So for actually interacting with it, we have the two things here. We have send attempt, which is just a wrapper around the send API. And then we have the get attempt, which will give us the data that we're supposed to prove. After we return the nonce, it will send that for us. So I'm gonna try to write code live, which always goes really, really well. So I'm just going to use this nonce and increase the nonce until I've hit a point where I have enough zeros. So I'm going to have a boolean. I'm going to say something like met, and I'm going to set it to false. I'm going to say while met equals false. And then I'll do a conditional here in a moment. Now if we go up to the top, we have the hash data function, which is what we need to do. So I'm going to create a thing called data to hash, and this is going to be equal to the string of our nonce plus the data. Then I can't remember the name of the function. We have hash data, so then I will call hash data with data to hash, and this will run over and over and over again until met succeeds. We haven't met it yet, but just want to quickly run that, and we can see here that it's generated a lot of random data. There are a lot of hashes, but we never increase the nonce. So the first thing we need to do is we need to do nonce plus equals 1, and then it will iterate over and over and over again. Now we need to have the function that will actually do the random portion of this. So we'll do we need to do only zeros. And we'll do only zeros of our hash data. And we need to give it an amount. So I'm going to say 5 here. Now, if this is true, then met equals true. And it will then return the nonce at that point. Actually, nonce one too many. So why don't we just do return nonce here. Okay, so now we're checking to see how many zeros our hash data has. And it has the amount that we need for this program to succeed to work. Now, I actually don't think I did this correctly in here. So I have a number here. So I'm going to set this to be 5. Now, if we go up here and we run our miner function, you'll see that it worked, but it's random. So it will take varying amounts of time, and this is kind of random how you do it. But there are some other factors at play. On my computer, it's really fast because I have an M2 Mac and it is pretty fast, but other computers will be slower. But also the quality of code you write will make it slower as well. So if you wrote this in C instead of Python, it would be much faster. But what if instead of doing it like this, what if I did this instead? If I did, instead of adding a number, I literally just added the string 1. And I did this over and over and over again. Now if I do that, it will be much less efficient because we need to hash more values every single time. You can also have a slower computer. There could be some logic errors in your code. There's a lot of things that could go wrong here. It's like, yeah, this one's not even finishing. So to recap, our goal is to get a string that get a hash, which is a transformation of some data that has 5 zeros at the beginning of it. And this is like Bitcoin mining. To do this, we append a nonce to the beginning of it, just like we did in the miner file. And all you need to do is modify this calc hash function, and it will return the proper nonce, which is called here, and then we'll call send attempt. And if the nonce actually does have enough zeros, then it will work. If you have questions, feel free to ask. Thanks for watching.